All right, guys, so this is review for exam 3. All right, so I'm going to be going over many of the questions that we have on your exam 3 review sheet that I sent to you in the email. All right, so number 1 asks you about the domain of some rational functions. All right, so domain of rational functions. All right, so I'm not going over all of them. I'll go over A. So A, you have a function f of x is equal to x plus 2 over x minus 4. So if you want to know what the domain is, you have to look at the denominator. And so what we're looking at here is we want to look at denominator and we want to say what value do we need for this thing not to be 0. But if x minus 4 is not going to be 0, it means that you can solve for this. Basically, you can add 4 to both sides. All right, and so what you end up getting here is you end up getting that x is not equal to 4. So that is a domain. But how do you write this thing in interval notation? So x not equal to 4 in interval notation, you would write it as, you would write this thing, x not being equal to 4, as you start out from the direction of negative infinity, and then you go up to 4, and you do not include 4. And union with that, again, you do not include 4, so you jump 4, and then now you don't go from 4 to positive infinity. So that is the answer to this particular question, all right? All right, just confirming, yes, that's correct. So we're still dealing with domain of rational functions. Again, we're still dealing with domain of rational functions. And so let's do another example. Another example, I'm going to do something with quadratics. So 1b, I have f of x is equal to 9x plus 2 over x squared plus 6x plus 8. And so I want this to not be equal to 0. So what am I going to do? I'm going to set x squared plus 6x plus 8 and make that not equal to 0. But if that's not equal to 0, what I need to find out is what happens if I look at this. What numbers do I have that would make this equal to 0? What I need to factor first. So I look for 2 numbers that multiply to give me a positive 8 and add to give me a 6. And so those 2 numbers are positive 4 and positive 2. So I have x plus 4 times x plus 2. We don't want this product to be 0. In other words, here I want to have x plus 4 that's not equal to 0, and I also want to have x plus 2 not being equal to 0. But if this is the case, I'm basically solving like I would an equation. And so what I get is I'm going to get x cannot be equal to negative 4 on that end. Similarly over here, if I solve, I'm going to be, I want, so this should not be in here, sorry about that. Negative 2 is obviously a negative 2, and negative 4 is obviously negative 4. What you're doing is subtracting 2 from both sides. So I'm going to get x is not equal to negative 2. So I want x not to be negative 2, and I want x not to be equal to negative 4. And so with, how do you say that in interval notation? In interval notation, this thing here, this becomes, you start from negative infinity, you're going all the way up to negative 4. All right, and then you jump from negative 4 and you go all the way to -2. So you're gonna jump, my mistake, you're gonna jump from, you have to watch the whole video. So you jump from -4 and then you go all the way to -2. Said the right thing, wrote the wrong thing. And then after that, you pass -2 and you're going all the way up to positive infinity, right? Okay, so that is what we have here. So this would be the answer. Okay, so again, this interval shows that x is not going to be equal to -4. So x is not equal to -4, that's what we're saying here. And x is not equal to -2, that's what we're saying here, and also here. And so basically all we're looking for is chopping up the number line, where there's a break at -4, which is what this first unit is about, and there's a break at -2 over here. All right? So let me show you visually what that means. So the reason why we have this, we're saying that x is not equal to -4. And we're saying here a little further right, x is not equal to -2, but x is everything else. X can be here, x can be over here, right? X can be over here. So in other words, x can be between -4 and -2. And x can be anywhere from going from -infinity up to -4. And then x can be anywhere going from -2 up to positive infinity. And so these are the only two things we want x not to be. So we're splitting the number line into 3 parts, basically. So that's our answer. All right, so continuing, we're going to go do another one similar to this. So it's going to be 1c. All right, so we're looking at 1c. So 1c, we have that f of x is equal to 2 over x squared minus 4x plus 4. Notice a point I did not make explicit in my the questions I've done so far is that when we're trying to find the domain of rational functions, what we are basically trying to find out is what happens to the denominator? Where is the denominator defined? That's all we're looking for. Where is it defined? Where is it not defined? And so again, here, the denominator is defined whenever it's not 0. So whenever x squared plus minus 4x plus 4 is not equal to 0, we're set, we're good. And so what we have here is, if you factor this, you should look for 2 numbers that multiply to give you positive 4, and then they're gonna add to give you a -4, and that's gonna be -2. I mean, they're gonna multiply to give you a positive 4 rather, and add to give you a -4. So the product is positive 4, and the sum is -4. And so the candidates we're looking for are -2 and -2. So we only have to do one because they're the same thing. This and this are the same. So we want x minus 2 to not be equal to 0, which basically means we want x to not be equal to 2, because 2, you can check for yourself, 2 minus 2 would obviously be equal to 0. So if we want this not to be 0, we want x not to be equal to 2, which basically means now is we look at the number line, and what we have here, again, this is the same thing, x is not equal to 2. What we have here, we look at 2. So x is not equal to 2. But certainly x can come from any negative number up to past 1, past close to 2. We can get all the way from -infinity, we can go all the way up until we get to 2, approach 2, but we can't actually include 2. And then over here, we can go from 2 to positive infinity, all right? And so how do we write this answer? we write this answer as, let me erase this part for you, since it's already up there. We write this answer as negative infinity up to 2 union 2 to positive infinity. So this is what, or in interval notation, what our domain is, right? The domain of f is going to be equal to, the domain of f is equal to negative infinity up to 2 parentheses union 2 to positive infinity. So again, all numbers except for 2 would give us our union here. All right. All right. So the last one, part D, for number 1, is actually the easiest one on the list. All right. Okay. So the last one, 1D, says that f of x is equal to x minus 4 over x. Again, we're only looking at the denominator. We're not looking at the numerator. The numerator doesn't tell us anything about the domain in this case, right? So we're looking at for x not to be equal to 0. Perfect, that's it. That's our answer. So that means that on the number line here, where I have 0, this is 0 here. That's 0, this number is 0, and this is just a hole. So we have a hole in the graph. All right, we have a hole in the graph right here. Okay. And so you can have everything going to the left here. That's included. You can have everything going to the right here. That's included, but there's nothing here. This is a hole right there in the graph. So that means that I can get any number I want to the left of 0. And you can get any number I want to the right of 0. And so that's our answer, right? A number to the left of 0, and a number to the right of 0. And we're good. Okay, so that's that. Okay, where did my answer key go? Anyway, let's move on. Okay, so we're going to be looking at number 2. Number 2 asks us to simplify some rational expressions, all right? So simplify. Number 2 is about simplifying rational expressions. All right, and so the first example is here, A. I have some expression x squared minus 16 over x squared minus x minus 12. And right away, I want to put a 1 here, right? Okay. All right, find my answer key. All right, so I apologize for the bell in the background. You're going to be hearing some of that. I am at home and I have a family member that needs our assistance sometimes, so sorry about that. Anyway, so what I want to do, I want to factor, all right? So the step is to factor. If I factor this, you should check for yourself. I'm going to get an x minus 4, and I'm going to get an x plus 4. Factor the numerator. And just to quickly check, I want this is basically, look at this. You should look at this numerator, difference between 2 squares, as x squared, really. What you have here is you have x squared plus 0x minus 16, right? That's really what you have. This is 0x here in the middle, right? So what you basically want is 2 numbers that multiply to give you negative 16 and add to give you 0. And so those numbers are going to be negative 4 and plus 4, which is what we have here. And similarly down here, you're looking for 2 numbers. You're looking for 2 numbers that multiply to give you and negative 12 and add to give you a negative 1. Well, obviously we have a hint, right? Because we have negative 4 as a hint. Because negative 4 plus 3 is going to be equal to negative 1. And then their product is obviously negative 12. All right, so again, this is what I left out above. This is going to be a negative 1 here. All right. So anyway, what we have now is the factoring of the denominator. So what I have here is x minus 4 over x plus 3. And so this cancels that. And so my answer for board space, I'm not going to write it over. My answer is just going to be x plus 4 over x plus 3. Again, x plus 4 over x plus 3. So I factored and I canceled. So factor and cancel, that's basically what happens. Those are the instructions that we need here. You factor and you cancel, all right? The answer is going to be x plus 4 over x plus 3. And that's the answer for number 2A on the review. All right, so just another one. Okay, so if you want to simplify, let's do another one. You want to simplify the expression 4t minus 2x over x squared minus 7x. Now, this is a little tricky, right? So what you have to note here is that, what you have to note here is that, look what's happening here. If you look at what's happening here, you're going to notice that when you factor this, the x is not going to be on the left, right? So you have to rewrite the numerator. And so you can rewrite the numerator as negative 2x, right? Plus 14. Again, remember, this is a positive 14, right? And this is basically, this is just another way in the numerator of saying a positive 14 plus a negative 2x. That's really what you're saying. You're saying a positive 14 plus a negative 2x, right? And so with commutative property, you can switch them around. So again, to subtract something is the same as to add its opposite, right? And so what you're saying here is positive 14 minus 2x is just going to be, become, when you use the commutative property, it's going to become negative 2x plus 14, positive 14. And so that is what you have in the numerator. And so now the denominator stays the same. And now we're ready to factor. So now in the numerator, I can factor out a negative 2. And so that gives me an x minus 7. In the denominator, I can basically factor out an x. And so that's going to give me x, again, minus 7. And so I cancel the x minus 7, and what I'm left with is just going to be negative 2 over x. That's going to be my answer, negative 2 over x, all right? So there are other ones that you can do parts B and C, but in the interest of time, I don't want to have a 3-hour video. So I'm going to move on to another question, all right? Okay, so moving on to another question. Okay, so number 3. So number 3 is asking us to perform some indicated operations, which is going to obviously involve simplifying again. So 3, the indicated operation is implied in how the thing is written. So what I have here is x squared minus ax plus 12 over x squared minus 16. And this dot means multiply. So that's multiplied by 4x plus 16. And I have x squared minus 4x plus 4. I'm not going to go over every single problem, as I said before, right? So please pay attention to the few. I'm going to go over one addition, one division, and one multiplication, one division, and then I'm going to go over a subtraction. Addition and subtraction are similar, but subtraction might be a little bit more tricky. So, all right, so what I have here is I can factor this. So I'm looking for two numbers that multiply to give you 12, but add to give you negative 8. All right, so that's going to be positive 12, and I need a negative 6 and a negative 2. So again, negative 6 times negative 2 gives you positive 12, and add up to negative 8. Negative 8, right? So again, negative 6 times negative 2 is positive 12. Negative 6 plus negative 2 is going to be negative 8. So the factoring is here. And so that's going to be x minus 6 times x minus 2. All right, okay. All right, and then, so that's it for that side. Down here I have x minus 4. This factoring is going to be x minus 4 times x plus 4. I went over that in the previous problem. And you kind of start getting suspicious. So one of these factors have to appear somewhere in the numerator, one of these. So I know it looks like it's going to be x plus 4, which it is. So if I factor this, I'm going to get x plus 4 on the inside, and I'm going to get 4x. So 4 times x is going to be 4x, and 4 times 4 is going to be 16. So that's factored. Something tells me that this factor from here is going to be down here. And obviously, this is going to be, we did this already. We just factored this in the previous problem. That was x minus 2 times x minus 2. Okay? So the perfect square. So this cancels this here. This cancels this here. And so in the end, I end up with 4 times x minus 6. I'll leave like that. I'm not going to expand that. And in the denominator, I'm just going to have x minus 4 times x minus 2. All right? X minus 4 times x minus 2 in the denominator, and 4 times the quantity, x minus 6 in the numerator. And so I'm checking my answers. Yes, my answer is correct. All right? So we're going to move on to another problem. Let's move on to a division, 3C. All right? Sorry if I'm not facing the camera a lot, but I want to make sure that what's going on the board is very clear, and I don't have a big board space. All right, so I'm going to be looking on 3C. Okay, so for 3C, I have this thing here, x squared over 1 plus x divided by x over x squared minus 1. And so I kind of prefer, so I'm going to do this right away. I kind of prefer if this were rewritten, this part as x plus 1. So on your paper it says 1 plus x. So again, you need to know that using the commutative property that 1 plus x is the same as x plus 1, right? And so now you still have this x squared over x plus 1. And now this division, so we're using a process, I think I mentioned it in class, it's going to be KCF, right? In the previous online lesson. So you keep the first denominator the way it is. Keep the entire fraction actually the way it is, right? And then you change this division to a multiplication. And then you flip, right? Keep, change, flip. You flip this and it becomes x squared minus 1. Denominator becomes x. And so now I'm going to factor. So you do KCF and then now you factor. So I'm going to factor and I'm going to get nothing to factor in the left part of the product. On the right part, I'm going to factor that into x minus 1 times x plus 1. Again, this is seen if you think of this as x squared plus 0x minus 1. It's the difference of squares, which I didn't get a chance to do a lot of that in class, but you can always insert a 0 where there's nothing, right? So x squared plus 0x minus 1. What multiplies to give you 0 and what multiplies to give you negative 1 and adds to give you 0? So obviously that's going to be negative 1 and positive 1, right? Those two numbers add to give you 0 and multiply to give you negative 1. So that's how you get that factor in. All right, and so now I can simplify. So now we're going to simplify. So the last step is to simplify. Okay, and so how do I simplify? I simplify by canceling. So this x cancels into an x squared. Remember, the x squared is really x times x, right? So one of the x's is gone, and so I have x left over. Or you can think of it as division. 2 minus 1 is going to be equal to 1. I have x to the 1 left. And now I can cancel this. X plus 1 cancels with x plus 1. So what do I have left over in the numerator, in the denominator? It seems like I have nothing left over, but technically that's a 1, right? Okay, so 1 times 1 is 1. Denominator is gone. And then the top, what do I have left? I'm just going to have x times x minus 1. So again, this comes out to be x times x minus 1 because the denominator only has 1s remaining. I have canceled out everything in the denominator, right? So that's what I have. Okay, so all right, so I'm gonna break this up. Okay, let me see how long. I don't want the videos to be too long, so I'm gonna stop here for this particular video, and I'm gonna make a new video for the next for the next part of 3C of number 3. Okay.